All right, hello, hello, hello. Welcome. Let's see, how is the stream looking? We just went live for the first time. Oh, there's my tea. Look at that. My spot of tea. That's a good tea, yeah? Little drop of milk. Let's see. How are we looking? All right, we're coming through. Coming through good. Good. Okay. Okay. Hmm. Yes, I am drinking tea out of an Alexander Keith's mug. Look at that. Alexander Keith's fine beers, but it is in fact filled with tea, as we can see over here. See, look at that. There's even two tea bags in there. That's how reliant on caffeine I am. It's Earl Grey, tea Earl Grey. Not quite hot right now. You know, tea Earl Grey lukewarm. It was formerly hot. Man's not. Man's not hot. Um, okay. Let's see. All right. Stream's looking good. We check the levels. Check, check. Checking the mic. Mic check. Mic check. Checking the mic. Okay. What I'm going to be doing on stream here is I'm going to be solving all the questions that uh, not that anyone struggled with, but any questions that I see out of work that I'm given to correct that I think is a good teachable moment or something that I want to go over, I'm going to go over those on stream here. I'm going to stream those live for anyone who wants to hang out and see it. I'm also afterwards going to save the video of me working through it and link students to those so you can go and watch it at your leisure. I'm also going to send any students who submitted the work, they're going to get a nice copy of this, the working that I'm going to be doing right here, sur le papier. Oui, sir, it would be sur le papier, oui, not dans. Dans will be in, sir is on, so I imagine it would be sir. Okay. Um, yeah, let's see how those light levels looking. Am I good? Am I good? One shoulder's not I'm not getting any like much shadows or anything. Okay. It's pretty good. Um, see, I got my background here set up. Let me just introduce you to my room. We've got my co-commentators here. We've got Hellboy, who's right over here. This little Hellboy figure. See him? We're back here keeping me company. We've got, additionally, along with Hellboy, we've got Lobster Johnson, also from Hellboy. And we have got Abe Sapien, also from Hellboy. There we go, right? It's pretty cool. I think it's cool. That's all that matters. Back up here, we got a pretty cool picture of the TARDIS on downtown St. John's. Over there, that's Godzilla in the St. John's Harbor, which I think is pretty rad. And that's just a painting of a Van Gogh, poster of a Van Gogh painting that I quite like. Maybe we'll alternate what stuff's in the background sometimes, just to spice it up a touch. Anyway, without further ado, I am going to get to the math tutoring. Now, as my stream description says, I am a college teacher. I'm a teacher in St. John's, Newfoundland. Normally, I teach math, on site, like at a school. But for social distancing, for COVID-19, we're not going to be on site. So I'm going to be doing this. This will give us a little bit of, hopefully, normalcy. It'll seem a little bit like, what it is to be in class. Let me just check and see how OBS is telling me I'm doing right now. Look at that. KBPS totally online. Drop frames, zero drop frames. Look at that. There we go. Yeah, that's the good stuff. That's what I'm talking about. Okay, so the first question I am going to solve is right up here in the corner. See this guy? See this guy over here? Woo! This is what is this? What even is? What even is? This is Math 1102A, Assignment 3, Question 21. All right, so this is Math 1102A, Assignment number 3. All right, and this is going to be question number 21. I'm going to start off with question 21. There we go. 21. All right. So these questions are for the Newfoundland and Labrador ABE program, or the Newfoundland Labrador High School curriculum, because that's what I teach. Uh, if you're in chat or hanging out in some other way and you want to ask me to solve any other questions, you see just down below, down below me, down here, you can see down below there's an FAQ, right? You're going to read down through that one. Basically, you can just describe to me the question or the topic as best you can. I'm not going to do anyone's homework for them, but I will gladly answer questions on any topic that you come up with. If you're unsure of how to explain what the topic is, you can go on your province or state's website, curriculum website, and get the outcome and tell that one to me. Now, I am possibly wasting my breath because I don't know if there's anyone actually watching right this second, and if anyone is, it's probably my students anyway. Okay. So, anyone who is one of my students already knows, you know, the outcomes and stuff. And you can just tell me the course name, the question. If it's a notes question, tell me the page in the book. I've got all the books here as well. Big stack of them behind me. Yeah. All right, well, let's get down to it then, hey? Question number 21 on assignment, Math 1102A, assignment number 3. This one is a good example of just fairly straightforward conversions, right? So what we're going to be doing here, it says the following rivers flow into the Atlantic Ocean: the Churchill, the St. John, the St. Lawrence, and Ottawa rivers. Convert the length of each river to kilometers and determine which river is the longest. Okay, well, first up, Ottawa. Ottawa River is just given to us. That's 1270 km. So we're done. Right, easy peasy. That one's sorted. Churchill. The Churchill is 856,000 meters. Now I do this one first because this is the easiest. Let me just move. Oh, boom cam. The boom cam got in the shot. So you know you're a professional. So you know you're a professional is when the boom is in the shot. It's good. It's good stuff. Okay. So I am going to do this one first, just because it's the easiest, right? It's meters, meters to kilometers, meters to kilometers. Kilo means 1,000, right? That's just a little side point about the metric system. Since kilo is 1,000, we know to get from meters to kilometers, we're going to divide by 1,000. So we're just going to do 86,000 divide by 1,000, right? Now it's a powers of 1, right? You know, so 3 zeros here cancel with the 3 zeros here. We get a simple 856 kilometers, easy peasy. All right, not much to that one. So the other two, a little bit more involved, right? Not much, but a little. So for St. Lawrence, we have 1,900 miles, right? So to convert that guy, we are going to need to use our conversion factor. Now, this this activity, I believe, does not include the conversion factor here. The one we are going to use is, the one we're using in this course is just 1.6, right? So the reason I bring up this question specifically is because it's a good opportunity to show us sort of in algebra how units cancel, right? So we know that our conversion factor we're going to use is there's 1 mile per, right? Because in math, divide is the same as per. 1 mile per every 1.6 kilometers, right? And this is our conversion factor. Put another bubble around that one. So the conversion factor is a mile per every 1.6 kilometers. And we've got 1,900 miles, right? But we want to get this into kilometers, right? So if I was to multiply 1,900 miles by 1 mile per every 1.6 kilometers, we'd have 1,900 divided by 1,900 miles squared divided by 1.6 kilometers. What's going on here? What we want to do is we want to get our kilometers to cancel, right? So there's two different ways of doing these equations. I'm going to show you one. first, which is a little bit easier. If it's 1 mile per 1.6 kilometers, we can equally say that that's 1.6 kilometers per every mile. Right? We can just flip that. It's still the same conversion factor because we're keeping our units over here. Right? So what we're going to do here now is 1900 miles multiplied by 1.6 kilometers per 1 mile. Now, when we multiply like this, when I was in high school, my math teacher told me that you just leave units out and put them back in at the end. But then I got to university and they were like, why the heck are you doing that? You should just leave them in there and you see how they cancel out, right? It is important and it really helps you determine if you're doing it right in the process while you're doing it, right? So here now we can cancel miles just like they were any other unit. Miles on top are going to cancel with miles on bottom, and then we're going to be left with a number of kilometers, which is exactly what we want. That's how we know we're doing it right. So I'm going to bring up yield TI-84 here. Look at that, right? Yeah, it's good stuff. So now we're going to go 1900 times 1.6. Y'all seeing that? There we go. Look at that. Look at that. Seems good. 3040 equals 3040 kilometers. So we know that the St. Lawrence is equal to 1900 miles, which is equal to 3040 kilometers. Would help if the way I moved my hand matched what my brain was doing. That would help. Sometimes it does, sometimes it doesn't. You know, it's hit or miss. Next up, now we have the last one. We had the St. John. Spelled St. John, of course, because that's the one in New Brunswick. If we're here in Newfoundland, and it is pronounced Newfoundland, then it's St. John's with an apostrophe S, right? Or just St. John's. St. John's, my son. All right, where are we? 736,000 yards. No, yards. Yards, what am I going to do? What am I going to do? What am I going to do? I don't have a conversion. I wasn't given a conversion factor on my formula sheet to convert from yards to kilometers. What am I going to do? I just got to throw up my hands and say that we're done, right? No, of course we're not. No. What we're going to do is we're going to convert our yards into miles. And, right, so we know that there are, per 1 mile, it's 1 mile per every 1760 yards, right? So again, 1 mile per 1760 yards. So now I can go ahead and I can do the same sort of deal that I did down here below, right? So I'm going to go ahead and multiply these guys. 736,000 yards multiplied by 1 mile per every 1760 yard, right? Oh, I've run out of space. Look at that. How irresponsible of me. These yards are going to cancel, and then we're going to get a number of miles. So we're going to do 736,000 divided by 1760 equals, right? So that's about 418.18 miles, right? And now we're in a unit where we do have a conversion factor that we're given on our test, right? If you Googled it, you could find a conversion factor directly from yards to kilometers, but when you're on a test, you're going to have to work with what you're given on your formula sheet. And what you're going to be given on your formula sheet is this guy over here and this guy over here. So we can just use 2 of them. So we're going to go ahead now and turn our 418.18 miles. We're going to multiply it again by the same conversion factor as before, 1.6 kilometers per every 1 mile. Miles are going to cancel with miles. We're going to be left with a number of kilometers. And I'm just going to, instead of rounding as much as I can, I'm just going to leave this guy on my calculator, and I'm going to go times 1.6. Wow. I'm going to get 669.1 kilometers. All right. So the question now asks us, all right, St. John, we're back up to here. So I'm just going to write it out here again. 669.1 km. How about How's about I just write these down here below? I'll write these in green because I like to use green to show that we're ready to go, right? We're done, we're done with figuring this out, so green means go. Ottawa, 1270 kilometers. Churchill, 856 kilometers. St. Lawrence is equal to 3040 kilometers. And then St. John with no S is equal to 669.1 kilometers, right? So determine which river is the longest. Well, quite clearly, the St. Lawrence is the longest. And anyone with some knowledge of Canadian geography will be able to back me up on that one. St. Lawrence is a rather large and important seaway. Okay, so total length of all four rivers in kilometers. Oh, that's a pretty complicated question, isn't it? Just going to go ahead and add those. Add a Reno cappuccino. So 1270 plus 856 plus 3040. Whoop, 3040. Pretend I can use a calculator. Plus 669.1 gives us 5835.1 kilometers. All right, great. So that is, this was part A. This was part, well, this was kind of part B. This is part A as well, don't mind me. So now we're going to be down to part C. What is the total length of the four rivers in miles? All right, then. Well, now we're just going to switch back, aren't we? But we've got our number of kilometers now, 5835.1 kilometers. Remember what I said earlier. We want all right. So remember what I said earlier. We want kilometers to cancel with kilometers. So, oh, I moved out of shot. I got my handy dandy little duct tape piece here marking where I should be, and I'm moving. I'm schmoving. All right. 5835.1 kilometers. We're not going to use this conversion factor because if we did that, we'd have kilometers squared per mile, which is not really the number that anyone's ever going to need. Not, right? But what we're going to do instead is 1 mile per 1.6 kilometers, right? This way, kilometers again are going to cancel with kilometers. And we're going to be left with, I'll do it crossways. This is not super disciplined to do it crossways, but you know, 5835.1 divided by 1.6, right? So that's going to give us 3646.94, I'll call that, miles. There we are. Done. Good. 1102A. Question 21. That one's done. Great. Wonder why I'm not seeing viewer numbers. So weird. Anyway, stream's still looking good. Let's see, what do we got? Zero drop frames. Yeah. Looks like I picked a good bit rate to do. All right. The next one that I'm going to do off this same assignment, I'm going to do one more on this assignment, then we're going to move on to another one. So let me bring up my PDF over here. The next one I'm going to do is going to be this one. Let's zoom in a bit so y'all can see it. Stephanie's car consumes about 8 liters of fuel per 100 clicks. Oh, I got to zoom out a touch. It's hard to read the whole thing at once, isn't it? Maybe I need to change the aspect ratio of this somehow. Okay. Stephanie's car consumes 8 liters of fuel per 100 kilometers. The gas tank can hold 55 liters. Determine the distance in kilometers that Stephanie could travel with 1 full tank of gas. Yeah, I'll do it on a different sheet of paper. This one's going to be relatively short, though. Actually, Hey, I'll do it on a different sheet. Why not? I've got enough paper here to do a few things. Does that come through? It does come through a little bit. Yeah, I can't really flip it over and do it, hey? Okay, so this is, again, this is still math 1102A assignment. Assignment number 3. And this is question number 22. 22. There we go. So, determine the distance in kilometers Stephanie could travel with one full tank of gas. Well, what sort of information do we have so far that we can use to start off? What we've got is that her car consumes 8 liters of fuel per 100 kilometers. How can we write that out in math? Well, we know that 8 liters, we know that per is divide, right? This is a super important lesson for a lot of different math courses. 8 liters per 100 kilometers. There we go. Right? The tank can hold 55 liters. So we want to get a number of kilometers, right? So if they can hold 55 liters, can we just go ahead and multiply this one by 55 liters? Well, no, we can't. I'll show you 2 different ways of solving this one. What we could do is if it's 8 liters per 100 kilometers, we could just as easily say it's 100 kilometers per every 8 liters, right? It's the same thing. If you burn 8 liters per driving 100 kilometers, then you drive 100 kilometers per every 8 liters that you burn. Right? Let me hold on a second. Okay. Just so you folks know, if you email me or something like that during the stream, I will see the emails, but I might not respond in email. I may just respond on here. Renetta, I can indeed do some geometry. How about you tell me what question specifically, if there's anything you're working on, and I will do that one after I get to the next thing after this. After this, I do want to do Math 3101A Unit 2 test. Then after that, I can go ahead and do some geometry stuff, no problem. But anyway, to carry on with this one. So this is one of the 2 ways that we can solve this. We have 100 kilometers per every 8 liters times by 55 liters equals what? Well, the good thing about multiplying it this way now is that our liters are going to cancel with liters, and we're going to be left with an answer in kilometers. What we're going to be left with is 5,500 divided by 8. And again, boy, I'm being undisciplined and going crossways. No, you should never go crossways. Don't do what the teacher's doing. 5,500 divided by 8. 687.5. 7.5 kilometers. Now, another way that we can do it, which is exactly the same, really, is we can use cross multiplying, right? Cross multiplying is super useful in a lot of cases. It's a really important algebra lesson to get, is how we do that. But to start off from the start, we have 8 liters per 100 kilometers, and we're saying she's got 55 liters, but that represents some unknown amount of kilometers, right? We can also do it this way with the cross multiply. Now, what does cross multiply mean? Why is it called cross? It's called cross because they cross over, right? The bottom left crosses over and goes up to the top right. The bottom right crosses over that one and goes up to the top left. So I am going to do what Mr. Critch in Lakewood Academy, Glenwood, circa 2002, recommended, and leave out my units for this one. But, you know. Anyway, so I'm going to have, on the left, we're going to have 8 times x. Over here, we're going to have 55 times 100. I'm going to cut to the chase and just call that 5,500. Now, you might be seeing that this looks an awful lot like this already, because now we have to solve for x. The way we're going to solve for x is divide by 8 to get 8 out of here. X is going to equal 5,500. I need to study for my test. Esther, okay. Great. You needn't use your real name as your Twitch name, but that's one way to do it. You could just use any old random string of characters and tell me what your name is when you first send me a message. But that's cool. That's fine. Yeah, I'll I'll send you an email after. I'll make a note to myself to do that. Hold on. Let me grab my to-do list. I'll just put that over here so I'm not showing everybody how much stuff I've got to do. Send Esther review sheet. All right. I will get to that after the stream is over. I'll send you a review sheet. No problem. If you have any specific questions you want me to solve on stream, just let me know. The course name, like whatever assignment or what page in the text it is, or etc., and I can get to it. Right. But anyway, that's just two different ways showing you to solve part A, question 22. All right, so that seems good to me for Math 1102A. Just so you know, like I said, if you have submitted that activity to me, and there is a person who has, basically what I'm going to be doing is I'm going to be correcting the stuff as normal, and then I'll be working through it on here and sending this to the student. So for example, if you were a student who just submitted me Math 1102A assignment number 3, you'll be getting this in a JPEG sent to you. You'll be getting this, and I'll send you a link to the video of me yammering on whilst talking about how to do it. And the video of me drinking tea out of my beer stein. Like, it's ceramic though, right? Like, it's great for tea. If it was glass, you're not supposed to necessarily put tea in average glass, right? Because the boiling water heats up the glass too fast, it can crack, right? But ceramic is great. I'm drinking my lukewarm Earl Grey. It's good. It's good stuff. Next up, I'm going to switch over to Unit 2 test, Mathematics 3101A. Now, back to my old to-do list. I'm going to be answering questions 2, 7, 17A, and 23. Yeah, where this is the test, let's see here. How's about I don't display the test up there in the corner, hey? Yeah, how's about I don't? How's about I don't do that? How's about I just leave up this page, and you'll have to trust me, I will tell you what the questions are and how much I'm going to solve of those. Just so y'all know, it's an unfortunate thing that I'm going to have to do, but I'm going to have to do it, and it makes for a ridiculous amount of work, is that over the course of social distancing, over the course of me sending out stuff as tests to people, going to have to be making up alternate tests like for everybody. It sucks. But so this questions that you see me solve on here from Math 3101A Unit 2 test are not necessarily going to be the ones that you get if you were doing that test. It's always going to be similar, but the numbers are going to be changed. So you're not just going to be able to, memorize these and go write them down or something. But let's see, 3101A is right here. Unit 2 test is right here. Okay. Yeah, I won't scroll through to show you the stuff because, secrets. One of the things that we have to do in this one, let's see, Math 3101A, Unit 2, test. Okay, so question 2. Question 2 is evaluating 10 factorial over 9 factorial plus 3 factorial. Okay, so these factorials just mean that number multiplied by every integer that's smaller than it down to 1. And including 1, but of course we know multiplying by 1 doesn't do anything, so who cares, right? We can just leave that. So we know that 10 factorial is equal to 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. Pretend that's the times. And then times 1. Right? I'm just going to write this out now. I'm not going to write it out every single time I do a factorial on stream because that would be insane. But I'm just trying to show you guys now. And anyone who's even not doing this course, this is still a teachable moment because a lot of you are going to have to do these types of questions eventually. And 3 factorial is 3 times 2 times 1. Okay? But as we see here, these are divided, and we've got Well, we've got a 9 here. I mean, that can cancel with a 9 here, right? And this 8 can cancel with this 8, and the 7, 7, this one, 6, 6, 5, 5, 4, 4, 3, 3, 2, 2, 1, 1. That all cancels. That all cancels, and we're left with just 10. So 10 factorial divided by 9 factorial is 10. And then 3 factorial is 3 times 2 times 1, which is 6. 10 plus 6 is unsurprisingly 16. Right? So, it's just a quick example of how you do those guys. How's the shadow level? Shadow level seems fine. I think I've eliminated a lot of it. Look, ooh, I've turned down the shadow detail in reality. It saves you a lot of GPU power to do that. Man, things run much more smoothly. Like my reality is running in like 144 frames per second today. It's sick. All right, so question 7. How many 3-letter words can you make from the letters Regina if you do not repeat any letters in the word? All right, so question 7. Now, 3-letter words, we notice here that we've got all the letters are different, aren't they? R, E, G, I, N, A. There's nothing repeated, right? So all we're doing is reorganizing 3 of 6, right? And does the order matter? Well, let's find. Would R, E, G, if that was a word, would that be the same as the word G, E, R? I mean, no, of course not. And when it says how many 3-letter words, they mean 3-letter combinations. You know, we're gonna treat both these as being words here. This is not an English activity. If it were, it'd be kind of interesting. You'd be like, well, you can get gin, you can get like um, uh, uh, age. You can get age, AGE. That's good. That's good. Um, air. You can get air, AIR. Right? Yeah. That's the kind of thing that I'm sure my mom has come up with could come up with like 3 dozen by this point because she plays this word game all the time. But anyway, this is a math question, and we're not actually concerned about words. We're concerned about combinations of letters, right? And the order does matter, right? And there are 2 things that we use to determine these. We use NCR and NPR, right? NCR is combinations. That's for when order doesn't matter, right? So in combinations, these 2 would be the same. But we know that in a word, obviously they're not. The order of letters is kind of important. So in PR is when the order is important. So we are going to go with NPR here. So what we have is 6P3. Because we've got 6 things, we're going to order them in 3 different ways. Now what you can do is you can get your old calculator here if you've got a TI-84 or such thing, and we can go 6, and then we can go into the math button right here. See that? Math. We can come over here to PRB, which means probability. We can pick NPR out of that one. And we can go 3, and then we can hit that, and we can be done. Right? Or what we can do is we can remember our formula, which is given to us on these tests. By the way, let me show you here. I believe the formula sheet is attached. Oh, formula sheet is not attached. Formula sheet I have to print separately. All right. Never mind. So back on over here. 6P3 is, well, NPR is n factorial over n minus r factorial. Right? C, of course, has a difference. C has also an r factorial out here. We're not dealing with C right this second, so we're not super concerned. 6P3 is equal to 6 factorial over 6 minus 3 factorial, which is equal to 6 factorial over 3 factorial, which, to show you, like I did up above, I said I wasn't going to write them out each time. I lied. Remember what I said I was going to eat you last? I lied. All right, so 3, 2, 1 cancels with 3, 2, 1. There we go. We end up with 6 times 5 times 4. 5 times 4 is 20. 20 times 6 is, guess what? 120. There we go. Easy peasy. Question 7 down. All right. Now we're going to go on to question, what do we got? 17A. 17A. Now with me not showing it on stream, this one's going to be a little trickier to explain, but I'll still work through it here. So, how many different arrangements are there for the word arithmetic? Question mark. How many different arrangements are there for the word arithmetic? Now, question 17A throws a monkey wrench into the works, and it says, if it must begin with M and end with C. Must begin with M and end with C. What the heck is going on here? Well, it's actually quite a bit easier than it sounds, really, because we have, how many letters in the word arithmetic do we have? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hey, that was tough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we know it has to begin with M and end with a C. So we're eliminating two of our letters off the start with a nice sound effect of me going pshoo. So all this kind of does, though, is it just reduces the number of letters that we have. That's it, right? Because there's an M here, there's one M, that one's gone. We're not sort of concerned with that one anymore for the point of A. C is gone now. So there's 1, 2, 3, 4, 5, 6, 7, 8. 8 letters that are possibilities for all these guys in here. So we write that down as an 8 factorial. Now, we're not quite done though. And this is the wrinkle, this is the rub. Right? Therein lies the rub. What we've got here, we've got some letters are doubled up, right? We've got a T here and a T here, so there's two T's, because there's a T and a T, and we've got an I and an I. Now those letters are the same, so it doesn't matter which T is in which place, it's going to be exactly the same, it doesn't matter which I. So we have to account for the fact that some of these things are, if they're interchangeable, basically. Some of them are interchangeable. So we have 2 factorial over 2 factorial because the two i's and the two t's. So now we can go ahead and work this one out. But what we'll have is our 8 times 7 times 6 times 5 times 4 times 3 times 2. I'm going to stop writing it to times 1 because that's just silly. And on the bottom, we're going to have 2 times 2. Now, I'm just going to have both those 2 times 2 cancel with a 4, but whatever, right? So what I'm going to have now is 8 times 7 times 6 times 5 times 3 times 2, which is 10,080. There we go. That is 17A for us, right? 17B gives another additional wrinkle, and it says if the consonants are all together. Now this is a nice cross-curricular lesson, isn't it? This is cross-curricular because we get to throw in this English teachable moment as to what vowels and what consonants are. Now the person that wrote this math test assumed you would know that, right? But if you don't, you can just ask the teacher because the teacher is going to be like, "Hey, this is a math test, not an English test. I can tell you that part." But the consonants, right? Consonants are in this word are R, T, H, M, T, C, right? And the vowels are A, I, A, I, E, I, A, I, E, I, A, I, E, I, O. Old MacDonald got laid off. E-I-E-I-O. All right. Okay. So kind of what we have here now are two sets of characters. right? Actually, tell you what, I'll pretend I wrote that in green. Pretend I wrote vowels in green. I'm going to do vowels in green. I'm going to do consonants in black. So we're going to have a set of 4 vowels, 2, 3, 4 vowels, and then we're going to have a set of 6 consonants, 1, 2, 3, 4, 5, 6. Right that. Okay. So there are 2 different sets, and these ones are all going to um, the vowels are not going to group together though, because we're told if the consonants are all together. So this one over here, this black one, this is going to be one individual group, and it's going to move as a chunk, right? And there are 6 different entries in that, right? And are any of them the same? Well, yeah, there's 2 T's, right? So we still have to deal with that. We still have to take the fact that there are 6 consonants, sorry, and 2 of them are T's. So it's going to be 6 over 2 factorial, right? And now, if the vowels were also a chunk that moved together, I would have to figure them out separately, but they're not. These are not a chunk that moves together, but these ones are. So kind of what happens is these all now form another large set, right? Because this chunk can go here at the end, but it can also move and it can go here between these two, or it can go here, or it can go here, or it can go here, right? This chunk of consonants can move anywhere around there. So really what we have is these 4 vowels, they all move as a group. They all move individually, sorry. And then these consonants here, they move as a group. So it's actually 5 elements that we have in the second situation. And the vowels, again, we have 2 i's that are similar. So it's going to be 5 factorial over 2 factorial. So you've got 2 sort of nested situations going on. One is the consonants inside. They're a group, they move together, but within the group they can switch. And then out here we've got the vowels and the set of consonants that make up this 5. So now what we're going to do to figure out our total number of different arrangements is we're going to multiply these together. Right, so we're going to have 5 factorial over 2 factorial multiplied by 6 factorial over 2 factorial. So now we're going to end up with 5 times 4 times 3 times 2 times 6 times 5 times 4 times 3 times 2 over 2 times 2. And I'm just going to cancel that with one of these 4's up here. Then I'm going to bring up my calculator and I'm going to brute force this one. 5 times 4 times 3 times 2 times 6 times 5 times 3 times 2. 21,600. There we go. 21,600. All the consonants are together. So there's more ways with all the consonants that are together than if it must begin with an M and end with a C, but that makes sense, right? Because beginning with an M and ending with a C kind of means that we're only dealing with 8 letters. Now down here we're back to dealing with 10. All right, so that's question 17. Pretty good. Again, right, if you submitted this test to me, you'll be getting a copy of this sheet in an email at some point today. Now, what else was there? Question, let's see here. No, I think that's probably good. It's probably good for 3101A Unit 2 test. Okay, so let's see. Got Renetta. Are you still watching? I don't know. Did you manage to find any specific questions that you wanted me to do? If you got any specifics for me, you can always let me know sometime, say before the end of the stream or sometime before tomorrow, and I can go back and get some of those done for you. I just don't know off the top of my head what sort of question you were looking for. I do indeed have a math set at home and all that, so I can do geometry on stream just as well as I can do any other sort of question. Right, now I'm going to move on to Math 1101C worksheet number 4. So let me just bring that up. 1101C worksheet number 4, there we go. There it is. So, this one, unfortunately, doesn't have an answer key with it. Like I don't have a key. So this morning now, partly what I've been doing is making up a key. And as you see, I'm making it up in different orientation because I'm making it to be able to be scanned once I'm back on site, and I can scan it and put it on SharePoint and all that. So let me just move my boom cam up a touch. There we go. Pretty good. It's pretty good. Um, yeah, so this is just some workings for the first 6 questions, and now the seventh. Um, and if you're a student that has submitted this worksheet to me, you're going to get this key and some corrections from your own work, basically, right? But I am going to now keep working down through, and I'm going to do a few of these questions on stream here while I go ahead and make this. You see my nice place marker? Look at that. I'm all professional, right? It's like I'm a theatrically trained actor. Look at that. I've got like the place where you stand on stage marked with some duct tape. Look at that. Okay. I'm going to keep alternating colors so that I can see it more easily afterwards. But I'm going to do question 8 right now. So let me just zoom in on this over here so you can see it up in the corner a bit. It might be a bit small right now. Let me zoom in on question 8 a touch. Question 8, zoom in a bit more. Come on. Zoom in, zoom in, zoom in. There we go. Marvelous. That's more than big enough to see. Hey, look at that. Okay. So, question 8. Question 8. These are, well, you're told different ways to solve these guys. Let me just go. For these ones, it says solve each of the following systems using either method. Now, either method, they mean either substitution or sort of like systems of equations. I'm going to carry on doing these ones through systems of equations. I think it's a good method to use. Now, where you can use multiple methods here, you can do several different things, right, to solve these guys. So I'm going to have, see, 2 over 3x plus 3y is equal to negative 43 over 3. Right? And then we have 8 over 3x. Oh, it's not a plus, it's a minus. Minus 2 over 3y is equal to 6. Right? Negative 43 over 3. And it's quite a daunting little fraction there, isn't it? But you know, oftentimes these things are going to work out to be something a lot simpler. Yeah, let me see. Let me just make sure that the okay, it's looking good. It's looking legible over there on the stream. Good, good, good. So now what I'm going to do is I want to multiply these by something so that either the number of x's or the number of y's are the same. The reason we're going to do that is because we want to be able to eliminate either the x's or the y's. Now I tend to look for what's the one that's easiest to eliminate one of the two of these guys, right? I'm going to be a little bit of a glutton for punishment on this one, and I'm going to decide to multiply this top one by 4. Right? So let me show you what's going to happen once I multiply this top one by 4. I'm going to have 2 over 3x plus 3y equals negative 43 over 3. And I'm going to multiply this whole side by 4, and I'm going to multiply this whole side by 4. Right? This is then going to become 8 over 3x plus 12y, because the 4 multiplies by both things inside the brackets. And over here, I'm going to have negative 43 times 4. So 40 times 4 is negative 160. 3 times 4 is going to be negative 12. So it's going to be negative 172. Negative 172 over 3. It's quite an unwieldy, large-looking thing, but I don't know. Who knows? Maybe it'll be easier by the time we're done, or maybe this one is just a gargantuan, you know, mess of a question. So I have now I'm going to move down the other one here. 8 over 3x minus 2 over 3y equals 6. Now, it's super important when you're doing these that you don't accidentally combine two forms of the same equation. I haven't seen anyone do that mistake, but it's an easy mistake to make. What I'm going to be doing is I'm going to be subtracting this whole equation from this whole equation here. Right? So the 8 over 3x's, 8 over 3x minus 8 over 3x, those are going to cancel and go, ooh, the pen's dripping. Those are going to cancel and just sort of go bye-bye, right? And that's what we want. But for the y's, we're going to have 12y minus, or plus rather, because it's going to be a subtract the negative, plus 2 over 3y. Now 12, we know, is the same as 36 over 3. So that's going to be 38 over 3y. Now I know that was a whole lot at once, but this is an academic math course that I'm doing here now. So as I'm going through it, because it's academic, I'm going to skip past a little bit of the nuts and bolts. Okay. Oh, we got a message. ¿Cómo estás? Oh, okay. I'll deal with that afterwards. So now I have negative 172 over 3 minus 6. 6 is the same as 18 over 3, of course. So we have negative 172 minus a further 18, right? So that's going to be negative 190 over 3. Now, just for good practice, I'm going to show you something that I would just ham-fistedly do here, just to see if it works. It does not. Oops. Okay. So I can't cancel anything out there. That's unfortunate. I will be able to cancel stuff in a second, though. Because I have 38 over 3y is equal to negative 190 over 3. That looks a bit bonkers, but just bear with me here. 190 over 3. To get rid of this fraction that's by the y, I'm going to multiply by its reciprocal. Its reciprocal is 3 over 38. Now we're seeing things are starting to cancel. So we're left with 190 over 38. Right? And that, whoa, look at that. Look at that. That's 5. Well, always worth plugging in the calculator and trying just to see. It's a lazy way. Lazy is practical. Excuse me. Okay, so y equals negative 5. Hey, now stuff is looking a bit more reasonable, isn't it? In it blood. Or basic blood. So I'm going to now go back up to one of these previous ones and stick this guy in there and see what I get, right? Stick that in for y. So I'm going to use my second one. 8 over 3x minus 2 over 3 times negative 5 is equal to positive 6. So that's 8 over 3x plus 10 over 3 is equal to 6. 8 over 3x is equal to, I'm going to subtract 10 over 3 from 6. Again, 6 is the same as 18 over 3. 18 over 3 minus 10 over 3 is going to be 8 over 3. 8 over 3x is equal to 8 over 3. Well, I think we can maybe already see what that one is. Oh, hey, captivating cacti. Welcome to the stream. I'm just working through some math tutorials for the some of the courses that I do, but I'm totally able to answer other questions, as you see down below. Down here. All right, so x is equal to 8 over 3 times 3 over 8. So x is equal to 1. Good, so now we know that I think I've messed up my pretty little answer key sheet, though, by doing this one way bigger than the other ones. So this one is POI, or the point of intersection, is going to be equal to 1, negative 5. There we go. All right, good stuff. That's an example of how you go through and do these ones. See if there was anything else that I needed to do for that. Okay, let's go down through another one of these. I'll carry on and do question 9. So let me bring up my. Oh, thanks. I appreciate that. Captivating cacti. That's yeah, that's great. Glad you stopped by. This is my first day doing this. This is part of our work from home efforts during the COVID-19 situation that we have unfolding, right? But this gives us a bit of a, semblance of still being in class to hear me here yammering on about mathematics all day. Right, so for question 9, 1 over 2x plus 3 over 5y is equal to negative 3. And here we have 3 over 4x plus 2y is equal to 1. Now this looks a little bit more normal. But one of the things here we're going to have to do is a half and 3/4, 3/5 and 2. They don't really work out super evenly, right? Like I can't just multiply 1 over 2 by any number to get to 3 over 4, right? So I'm going to have to multiply each of these two by something this time, right? So what am I going to pick? Well, I want to pick something that's going to be as easy for me as it possibly can be, because that's the goal here, is to get it to be nice and easy. Right, so if I was to multiply 3 over 4 by 4, right? Say I was to take this one, 3 over 4x plus 2y equals 1. Say I was to multiply this full side by 4, and then this full side by 4, like so, right? It's going to come out now to be 3x plus 8y is equal to 4. Right? So now what I'm going to do is I'm going to take the other one, because you always had, you can't, this is what I mentioned in the last one, right? If I made a second version of this one and subtracted the two of them, I'm going to get 0 equals 0, and then I'm going to be all confused for a second. So I've got to go with the other one. I've got to go with 1 over 2x plus 3 over 5y equals negative 3. And I'm going to now choose to multiply both sides by 6. Right? So I'm going to end up with 3x plus 18 over 5y is equal to negative 18. But now I've got two that I can combine. Okay? So I'll just write the other one down here below once, so I save myself a little bit of writing. Right? So I'm going to subtract this whole expression from the whole expression above here. So 3x minus 3x is 0x. That was kind of the point. 8 is the same as 40 over 5. So 40 over 5, so 18 over 5 minus 40 over 5 is going to be negative 22 over 5y. Right? And I'm going to have negative 18 subtracting 4 is going to be negative 22. All right. Yes, good. It looks like stuff is going to cancel out, doesn't it? Good stuff. So y is going to be negative 22 multiplied by 5 over 22, negative 5 over 22. This is going to cancel with this. The negative is going to cancel with the negative. Right? Y is going to equal 5. There we go. All right. We're probably on track. It's a little bit of metagame. It's a little bit of metagaming to think that, oh, I'm probably on track with my math equation because it's working out with like whole numbers. I mean, it works. It's true. A lot of times teachers will make equations so that they do work out with exact numbers. It won't always be the case, but here it is. So, if you're on a test or something, you can metagame it a little like that, but try to avoid that sometimes. Because sometimes we'll get crafty teachers, right? We're crafty people. We're always trying to catch you. We're just catch you, make sure. Right? So sometimes it won't work out to be a nice round number, but this time it did, or does. Anyway, so I'm going to take this now and go stick that back up into one of my starting ones. So 1 over 2x plus 3 over 5 times 5 is equal to negative 3. So a half x plus 3 is equal to negative 3. A half x is equal to negative 6. X is equal to negative 12. So our point of intersection of these two lines is going to be negative 6, negative, oh, sorry, what am I doing? I wrote down the wrong thing. Hold on. Our point of intersection of these lines, negative 12, positive 5. There we go. All right. Good stuff. So that's part of 1101C worksheet number 4. And like I said, for this one, it's going to be a little bit longer to get it done because there are there was no key beforehand, so I'm going to do those up nice and proper, send them off, have a nice key for us. Okay. Yeah, maybe I'll return to that activity in a bit, but I think the student who is doing that one should have there should be some fairly good examples to send as a video, and I'll also send off the whole key once it's done. Now let me go and check. Again, if you're one of my students who's out, oh, Jackie, would you mind if I share this with other instructors? Yes, please. Go for it. Yeah, great. Send them the link or whatever, and just let them come heckle me. That'd be great. And within, if there any other math teacher has students doing the same courses, I have all the curriculum documents here downloaded and ready to go. So if they just tell me what assignment and what question they need me to do, I can go bring that up real quick. Right, how long? We've been live for an hour. 16 drop frames. It's more than zero, but it rounds to 0.0% OBS is telling me, so it's all right. That's half a second. Half a second of drop frames. I'm okay with that for now. Okay, so Renetta asked if I would be doing any geometry. Again, Renetta, you can let me know if there's anything that you want me to do specifically. I will go, let's see here. I'll go grab Prism Math Blue and my math set. Here we are, Prism Math Blue, math set. Now let's see about doing some geometry. Let me just flip to a random page and start doing some questions, and you can tell me if that's the kind of thing you wanted or not. Let's see here. Where does the geometry even start? Pretest geometry. All right, the pretest is a reasonably good one because you don't actually have to do this page. You're not actually responsible for this one. So the fact that I'm showing you the answer key to this page should be totally fine because you haven't got to actually do this one. Right? But here we've got name each figure below as shown. Right? Now the deal with naming the figures. Come on, camera. Come on. Focus. 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 All right. So the deal with naming these figures, right, is we basically need to look at the little clues that it gives us on here as to which figure is what. We know that this is a ray. We know that this is a ray because it has an arrow on one end, which means it keeps going on that end. And it's got a dot on this end, which means it stops here, right? So we call this ray XY. So if I was to grab a sheet of paper and write down the answer that I would want you to say for this question, I would say question 1. Now this is page 156. Right? So again, these are not questions that you are responsible for yourself. So I'm just going to go through and show you, but it's got a good smattering of like the different stuff that you have to do in this unit. Right? So for question 1, you would either call this ray XY. I'm okay with you writing it out in words. You do need to know that it's called ray. There is a question I'll tell you right now. There's a question on your test that does ask you to write it out. Or the symbol that we will use will be XY with an arrow going from the X to the Y. Now that direction is actually important because as we see up here, right, the X is the end with the dot, and past the Y, the arrow keeps going. That's what that means there. What was that? Okay. So this next guy, question 2. Oh, sorry, that's not question 2. It's question 1B. Question 1B, this one here, this is fairly straightforward. Like you see on there, all this is just angle. You can either write out the word angle or use that as an indicator. And it needs to either be PQR or angle RQP. I wouldn't expect you to write out or like that. You don't need to write out both of them, but you had to give one of the two. The reason why it has to be these two is because as you see here, the Q is the part on the corner of the angle, so it comes down like this. So since the Q is the corner, the Q needs to be the one that's in the middle. The other two can switch around for either side. So that is an angle. C, then, is going to be, C is what we call a line segment. It is important to call it a line segment with both words because this one here, yeah, the document cam is maybe a touch blurry for the actual printed page here. Can't really. I wish I could go out and get another nice 1080p HD cam like I'm using for my face cam, but you know. Anyway, trying. I can offer you a nice egg in these trying times, right? Shove some memes in here on my stream, you know, even though I'm doing math. Anyway, back on topic. It's a line segment because it ends on both sides. It's a dot here and a dot here, right? Which means it doesn't continue past either. So that's just ST with a line over the top and no arrow on either side. 1D then, we see 1D is just straightforwardly, well, that's a line. That one's a line. It's just line MN, and the way we would write it as a symbol is an MN with a double-headed arrow on top of it. Right, now for question, how about, tell you what, I'm going to have to slide this book out of here because I'm going to need to have more space to write. Unfortunately, I don't have a digital version of these, so I can't stick them up in the corner. Actually, yeah, I guess I should just, I'll just put a white screen up here in the corner. Yeah, I see. That's a good to do. Digital Prism Math. See if that exists. That would be a good get for sure. Okay. Question 2 then. Question 2, as we're seeing, question 2 is again a line. Tell you what. Fold that guy across. Okay, so question 2 then. 2A is going to be line JL like that, or LJ, either one, I don't care, as long as you have the word line and or this line at the top with no arrows on it, right? So, oh, sorry, not line, it's line segment. Look at that, I almost got one wrong. Boy, oh boy. Boy, oh boy, call in and complain about that one. The teacher almost got one wrong. What face? What face? Okay. This one, B is a line. It's line AB, right? And it's got a double-headed arrow on top of the AB, or BA, whatever. As long as it's a double-headed arrow, right? C then is an angle. Angle CDE or EDC, either one, right? But again, the vertex, the D, needs to be in the middle. This one over here, 2D is 2 dimensions. 2D is a ray. This one's important to remember that when you write it down like this, GF, the line ends at G, the line continues on past F, so your arrow needs to be pointed that way. Simple, right? No problems. I'm going to avoid messing with that sheet too much because my nice gel pens, the ink might smudge if I am messing with it too much before it dries well. I don't want to have my nice workings all shattered with smeary ink. So here, use a ruler to compare the lengths of the sides of each triangle. So you're going to use, you know, a ruler. Right? And you're just going to measure them. And you'll see that this side and this side are the same length, and this side is not, meaning it's an isosceles. Here, they're going to let me mark you right if you say isosceles. I don't know if I'd do that or not. But here, if you measured them all, you would see that they are all the same length, therefore it is an equilateral triangle. Equilateral triangle. Over here, this one's scalene because all sides are different length. Right? Nothing to it. Now, this one. This is the one. These are the ones. Sorry, these are the ones. These are the ones that boil people's noodles in these courses. Let me tell you. Write an R in each rectangle below. Write an S in each square. Write an X in each rhombus. Rhombus. Okay. So this one over here has just got an R. It's just got an R wide. Well, we had to know the definitions of these three guys. Rectangle, square, rhombus. Rhombus. Now, a rhombus, what is that? That's a four-sided figure with all the sides equal. All the sides equal length. But the angles don't matter. Angles can be anything at all. Right? A square is a four-sided figure where the angles are equal length. Sorry, the angles are all 90 and the sides are all equal length. A rectangle, of course, is a four-sided figure where all angles are 90, but the sides can be unequal. Right? So it's worth remembering that any square is also a rectangle, any square is also a rhombus. But, as we see here, rhombuses are not necessarily squares or rectangles, and rectangles are not necessarily squares or rhombuses. They are all quadrilaterals. Quadrilateral meaning just a four-sided, two-dimensional figure. Right? So that's why this is R, this is RSX, and this one is X. Okay? Again, stuff like this, that'll be on your test. Absolutely, it will. Tell whether the following are parallel lines or intersecting lines. Oh, well, these first two are pretty easy, like especially this one, intersecting. Well, I mean, obviously it intersects. You see it. It's right there. You can see that. These ones are intersecting. We know that because if we were to take this top one, say, and continue it over like that, it would cross over here and it would intersect. So because these have arrows on them, those arrows mean that they continue in those directions infinitely. So if you were to continue this line or this line down, you would see that it would cross this line over about here. So those are intersecting. These ones are parallel. Parallel meaning that they will never cross no matter how far they are extended. Okay? So, Renetta, if you have any specific questions for geometry, you can let me know. You can let me know now during the stream and I can do some up. Or you can let me know at any point and I'll do those tomorrow on stream. And again, like I'm saying, I will always send students the paper that I'm working on, right? I'll either send it to you via email or text if you don't have email, though if you don't have email, you're also probably not watching the stream, so you know, I'm sort of wasting my breath there, aren't I? Okay, what else do I have? We go back to those. Oh, hit my document cam. Real professional. Consummate professional. So, let's see, I could go back to worksheet number 4. Have I gotten any other requests? No, no other requests from the audience. Anyone in back? Anyone in back? Hey! Anyone back there? Got any math questions? No? I wonder if that worked. Does that sound ear-splittingly loud? Am I going to have to, when I do my yell takes, am I going to have to move to a different room first? Maybe I will. Okay, yeah, I've worked through a lot of those ones that I've been talking about. Let's let's bring up this question here. Let's go with this very last one here. This is one that I said I wasn't going to do, but I've decided to do it anyway. So let me just zoom out a touch. This one here, this is a question that, it's one that Troy submitted. Yeah, I'll send that one to him along with the rest of the stuff. But anyone watching maybe will learn a little from seeing me go through it here as well. So how many 5-card hands consisting of 3 aces and 2 other cards that are not aces are possible with a regular 52 card deck. Okay, well, so there's a few pieces of information here that are really important for us. One, 5 card hand, right? 5 card hand. We're playing, we're playing 5 card draw, or we're playing, 5 card stud, which is a great game, but no, it's actually not how it will be dealt in 5 card stud, is it? Or we're playing triple draw low ball, right? That's a great game. If you want to talk poker, different probabilities associated with different types of hands. Yeah, let's do that. That's more than willing. But anyway, 23. Oh, I am zoomed in too far. There we go. Question 23, right here. So how many 5 card hands? 3 aces and 2 other cards. Well, how many aces are there in total? There's only 4 aces, right? There's only 4 aces in a full deck. But we have to, here we're going to either be using our NCR or our NPR. Actually, I should write both those lowercase. Lowercase is usually how those are written. NPR and NCR. Well, which one are we going to use in this case? Well, we know that C is for combinations, order doesn't matter. P is for permutations, order does matter. And if you're dealt a 5 card hand in poker, does it matter if the ace you got was first or last? No, of course not. No, it doesn't matter at all. All that matters is that you got the ace in your hand. You can rearrange them as you want afterwards, although it might be a bit of a tell. It's probably a bit of a tell to people, like if they see you moving cards in your hand around and putting some together and some apart, they might be like, hey, that guy's got a pair. So maybe don't do that. Try to do that as little as possible. Anyway, so it's not a poker stream. So we're going to go, the moral of my story is that we're going to go with C here, right? Because the order doesn't matter. So to get those 3 aces in the hand, that's 4 choose 3, or 4 C3, because that's the different number of ways that we can get those. And 2 other cards that are not aces. Well, how many cards in the deck are not aces? So there's 52 cards in the deck in total, right? So there's going to be 48 other cards, other non-ace cards. So it's going to be 48 C2, right? And we know from before that NCR, right? If we were to do that out by hand, say we didn't have a graphing calculator, we couldn't just plug it in like I'm going to now in a second. Say we had to do it manually. We know that NCR is n factorial over r factorial n minus r factorial, right? So if I was to do 4C3, that's going to be 4 factorial over 3 factorial 4 minus 3 factorial, which is 4 factorial over 3 factorial 1 factorial, which is just 4. Right? Because it's going to be 4 times 3 times 2 divided by 3 times 2, so it's going to be 4. 4 different ways to get those. So if we were to instead do 48C2, we're going to find that's going to be 48 factorial over 2 factorial 48 minus 2 factorial. It's going to be 48 over 2 factorial times 46 factorial, which is going to reduce down then. Boy, my penmanship is going to need some work if I'm going to be streaming math. Hey. It's going to be 48 times 47 over 2, right? Because the 46 down, it's going to cancel, just to show you over here what I'm doing. Say 48 factorial, to reiterate from earlier, is the same as 48 times 47, don't mind me, 48 times 47 times 46 factorial, right? Over 2 factorial times 46 factorial, so I can see it as that, canceling with that. Yeah, I'm not actually going to write out every every last bit. Right, so then 48 times 47 over 2. I can do that in here. Or what I'm going to do over here on my old TI-84 is I'm going to go show you how to do that just by normal. Like, so we're going to go 48, then I go over to the math button, math over here, math button. Probability, I'm going to move over to. I'm going to pick up NCR, like so, and I'm going to go 2. And we're going to see that that's 1128. Right? If I did 48 times 47 divided by 2, we would see that that's also 1128. So it checks out. Remember, if at any time you're on a test, you've got one of these guys, right? Or just or another calculator. If you're at my site, you can borrow one of these from me for a test, or you can use whatever other calculator you have. But always, 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 always use it to check your working, right? Maybe it slipped your mind. Maybe let me tell you these things. When in a pinch, they can help you out a ton to check your work. Either way, so we've got 4 for our first term, 4 for this one, 1128 for this guy. So all we end up with then is 4 times 1128. $45.12. That is the answer. How many 5-card hands consisting of 3 aces and 2 other cards that are not aces are possible with a regular 52-card deck? 4,512. Right? Good. Good stuff. So, I'm gonna wet my whistle here slightly. Now, I seem to have gotten to the end of the different things that I said I was going to cover today. So, next I'm going to go back to the 1101C worksheet number 4. Right. Let me just bring that back up on my document cam, or on my document feed rather. Document cam is here. Document feed is here. Let's see, 1101C. Here we are. Zoom out a touch. All right, so I've done questions 8 and 9. Let's do question 10. That seems to be the one that would come after, doesn't it? Yeah, I mean, that makes sense, right? Question 10 comes after question 9. It's amazing. Now, for these, I'm going to have to do these in portrait orientation, not landscape orientation, just because I am doing these to scan and to put onto SharePoint for afterwards. So let me bring my strim back up. Here we go. Still looks okay. Right. So now this is Math 1101C, worksheet number 4, answer key. Okay. So here we are now, question 10. Again, these are systems of equation questions. There are several different ways of doing these. You can do them by substitution. Substitution is where we rearrange one of the questions. Let me do this one via substitution. It might be a touch more involved to do it by substitution, but I'm going to do it for this one. So 3 over 4x minus 3 over 5y equals negative 19 over 20. The next one is 3x minus 4y is equal to negative 13 over 3. Okay, so the substitution method, what I said, is I'm going to rearrange one of these guys to get one of the variables by itself. And then I'm going to take that and substitute it back into the other one. It's going to look like a proper mess in this question, but it'll work. It'll work in the end. So what I'm going to do is I'm going to rearrange this to get x by itself. So I'm going to rearrange the second one here. I'm going to call this 3x is equal to negative 13 over 3 plus 4y. Then x is equal to 4. I'm going to rearrange these. 4 over 3y minus 13 over 9. Boy, that sure is something, but that'll work. The important part next is that again, right, like I was mentioning before when I was doing these questions, it's super important to make sure that we're substituting this back into the other question. So I'm not going to substitute it back into here. No. We ain't going to do that. Because if we did that, it's just going to work out to 0 equals 0, which is true. It's true. It's not super useful, but it's true. Instead, I got to put it back into this one, right? I got to put it into the other one. So I'm going to have 3 over 4 outside of, now I know x equals this whole phrase, right? 4 over 3y minus 13 over 9. Then we're going to still have our minus 3 over 5y equals negative 19 over 20. So I'm going to go through and multiply these guys out, right? This one's going to multiply by that term and by that term, because of course they are separated by a plus or a minus, in this case a minus, which means when we're multiplying, we need to multiply both things in the bracket by the thing outside the bracket. Here then, these ones are going to cancel. You're just going to have 1y, right? Minus, let's see. So the 3 is going to cancel with the 3 is going to cancel with the 9. It's going to become 1 over 3, so it's going to be minus 13 over 12. Again, right where this is an academic course, I'm going to skip some of just the writing out the arithmetic. Minus 3 over 5y. Going to give us negative 19 over 20. Now let's rearrange these guys to be a little bit neater. So we've got y minus 3 over 5y is going to be 2 over 5y. That's how many y's are left. And that's going to equal negative 19 over 20 plus, yeah, this is right, plus 13 over 12. Holy moly, this is going to be a pain in my, places that accept pains. So 2 over 5y is equal to, yeah, because this is a G-rated stream, right? Just down there below. It's a G-rated stream, goddammit. So I'm going to multiply this by 3 over 3 in order to make the bottom 60, because 60 is the LCM of 20 and 12. Right? So if I multiply this by 3 over 3, I'm going to end up with negative 57 over 60. This one here I'm going to multiply by 5 over 5. So that's going to be 65 over 60. Right? So then we're going to have 2 over 5y is going to be equal to, that looks like it's going to be 8 over 60. 8 over 60. So I can say 8 over 60 is the same as 4 over 30, which is the same as 2 over 15. So 2 over 5y is equal to 2 over 15. Then I'm going to go ahead multiply across. Boy, oh boy. Y is going to equal to 2 over 15 times 5 over 2. 2 is going to cancel with the 2. 5 over 15 is the same as 1 over 3. Y is equal to 1 over 3. All right, so all this ridiculosity here got us down to y equals 1 over 3. Maybe I'm not. Maybe I'm not going to put this one in as the answer key. This is a little bit long-winded. Not that I'm long-winded or anything. Not that I've been talking for an hour and a half straight about math. And I'm probably going to talk for an hour more. Anyway, so y is equal to a third, as we see down here, right? So now I'm going to go back and stick that into one of the questions up here. So let me do 3x minus 4 times 1 over 3 is equal to negative 13 over 3, like that. Right? So 3x minus 4 over 3 is equal to negative 13 over 3. 3x is equal to, so I'm going to add 4 over 3 to both sides. 3x is equal to negative 9 over 3, or 3x is equal to negative 3. So x is equal to negative 1. There we go. We got there. We did it. We did it, Reddit. We got there in the end. Okay. Now what we got to is the point of intersection is negative 1, 1 over 3. And if I was to take these two lines and graph them, like in my jolly old TI-84 Plus, or on Desmos, or some other useful place, we would find that this is the point of intersection. It's a super good way of testing and making sure that you're right. Don't just write down the point of intersection, though. Like, if you get a question like this on a test or an assignment, and you just give me the point of intersection, I'm going to assume you just went to Desmos and plugged it in. Okay? It's fine. It's good to go to Desmos and plug it in. It's great that you know how to do that. But you also need to show me some workings. Right? It's totally great to go there and use it to check. But it's not totally great to use it instead of doing out all the rest of Um, yeah, maybe that's a good teachable moment too to show you how to check. I'll do that for a different one. Right? Because in order to check with a TI-84, in order to check with this guy, right, what we have to do is if we go over here to our y equals screen, which is this button, we notice that everything is just listed as y equals, and then you got to type in the line. So you need to rearrange all these, you need to solve these for y. But if I was to do that, you would see that it would actually work out over here. So let's do that now. That's fun. I am told by people who know more about streaming than I do that the entire point of streaming is to find more content. So this is more content. Here we go. Contentarino. I'm going to take this guy, say 3 over 4 x minus 3 over 5 y equals negative 19 over 20. I'm now going to solve this for y. So negative 3 over 5y equals negative 3 over 4x minus 19 over 20. Y is equal to negative 5 over 3 multiplied by negative 3 over 4x minus 19 over 20. Right? So I'm going to have then y is equal to these ones here. The negatives are going to cancel. These two 3's are going to cancel, so we're going to have 5 over 4x. Right? Over here then, the 5 and the 20 is going to be over 4, so it's going to be plus 19 over 4. Is that right? No, plus 19 over 12. Plus 19 over 12. Yes, because it's going to be, yeah, the 5 and the 20 are going to become 1 over 4. Then that 1 over 4 is going to multiply by the 3 to make 12. The 19 is just going to hang out up here, not doing anything. All right, so this is one of the lines punched into a form that I can plug into my calculator. Let me show you. Let me show you how to do that. So I've got my TI-84 here. It's a wonderful piece of technology that's helped me bullshit my way through many a math course, many a math exam that I maybe shouldn't have taken, or maybe should have studied more for. Anyway, not to brag about how bad of a student I am. 19 over 12. Now, I'm trying to be very disciplined here and write them in brackets. Brackets are never, if you use brackets correctly, you open them and close them, you know, it's going to help. It's always going to help. Let me move this, hold that better. There we go. So that's how we write it in. 5 over 4x plus 19 over 12. Now, if I go over here to trace, there it is. Look at that. Yeah. Haha. TI-84 has found that line for us. Good stuff. Now, I'm going to rearrange the other one. Right, so what I have is 3x minus 4y equals negative 13 over 3. Okay, so again, I'm solving for y, so the x needs to move. So it's going to be negative 4y is equal to negative 3x minus 13 over 3. Then y is equal to 3 over 4x plus 13 over 12. Right? So now I can go ahead and plug that one in too. In my y equals over here. So I have y is equal to 3 over 4x plus 13 over 12. Close that up. Go back to trace and we see, hey, look at that. Oh, they crossed. But where did they cross? Was it at negative 1 positive a third, I wonder? Well, can the TI-84 tell us? Well, it can tell us in a few different ways. One, if I just type a number in on this screen, I can go to x equals negative 1, and look, when x equals negative 1, y does equal a third. Look at that. And if I was to go to the other line and do the same thing, hey, it does. Wow, look at that. There's also another way we can do that. We can go to calc, right? Whoop, this is hard to balance. Maybe I should get a box or something to put under this so I can prop it up. Calc right here. See that? See that? See that on my low res little screen here? Like this one's a much higher res camera. I'm ruining your dreams. No. I usually am like a human quaalude. I'm able to, you know, just put people to sleep by talking to them. So, you know, if you're dreaming about math whilst I'm talking, I guess my job's done. I guess I guess that's the good thing, right? Like the whole point is to get you dreaming about math. So, Let me go to calc. The way I'm going to do that is I press the second function button and I press this one. Oh, I got to do it. I got to do it properly. I'm going to go down here then to intersect. Right? I'm going to pick one line. There we go. Pick the other line. There we go. It's going to say guess because the calculator is going to round. I'm going to click yes. Hey, look at that. Intersection. X equals -1. Y equals 0.33333333, which is 1 over 3. And look what I found. Look what I found earlier. Point of intersection. -1, a third. So that's actually 2 different ways of solving this one. I'm actually not going to use this as my answer key. I don't think I'm going to have to do that up with the normal stuff. But there we go. Math worksheet number 4, question 10. Human Quaalude. That's right. That's me. Very sleep-inducing. Grab some more blank paper. Okay, so now I'm going to, let's see, now I'm going to actually make an answer key. So this one is Math 1101C worksheet number 4 key. I won't bore you with going through question 10 again because I've just done that one 2 different ways. I am, however, going to leave myself some space for when I write it out later. I'm just going to go on to question 11. Just going to do question 11, but I'm going to do this one the way that I recommend doing, which is sort of using systems of equations. Question 11. When I do my answer keys, I like to alternate what color I use, just so it's easier for someone reading it to tell which working belongs with which question. So here we have 4y minus 3x equals -4, and I have 4x plus 2y equals 5. Now here, you see, they pulled a sneaky on you. They pulled a sneaky, because what they did here, as we see on my document feed, is they rearranged these guys. Look, this was a y, and this is a y. So the y was on the left here, but now the y is on the right here. So you gotta pay attention to that. They're apt to do that sort of thing. And by they, I mean the powers that be, the nefarious evil teachers who are making these activities that are, meant to gauge your understanding of the material. Those people, right? So what I'm going to do is rearrange these guys. So I'm going to rearrange the second one to be 2y plus 4x equals 5, or I'm going to multiply this side by 2 and this side by 2 to get 4y plus 8x equals 10. So we can do whatever we want to the left and the right, so long as we do the same thing to both, right? So now I'm going to bring down my other equation, which was 4y minus 3x equals -4. And I'm going to subtract them. I'm going to subtract that full equation from the full equation above it, right? So 4y minus 4y is 0y, and that was the whole point. The point was to get rid of the y's. Now, 8x minus -3x is the same as 8x plus 3x, which is 11x. And then 10 minus -4 is the same as 10 plus 4, which is 14. So now we have one where, like I said earlier, right, we can't always metagame it, right? Because sometimes they are going to work out so that they're not going to be even numbers, right? So x here is going to be the fraction 14 over 11. It's totally fine. It's totally valid. Just it might not be what you expected. Okay, so now I'm just going to go back and stick that into one of our equations up here. So 4y minus 3, 14 over 11, equals -4. Now, stop me if I'm doing anything wrong. It's entirely possible. It's entirely possible when you do, like, you know, a dozen math problems on stream that I'm going to mess something up. But 4y minus, now that I'm saying that, I'm psyching myself out, right? I'm not even, 42 over 11 equals negative 4. So now we have 4y equals negative 4 plus 42 over 11. Negative 4, of course, is the same as negative 44 over 11, right? So negative 44 plus 42 is going to be 4y is equal to negative 2 over 11. So y is equal to, so we're going to divide both these by 4, so it's going to be negative 2 over 44, which is going to be negative 1 over 22. So there is our point of intersection. Our POI, or our point of intersection for those two, is going to be 14 over 11, negative 1 over 22. Right? So, let me check, see. I've got a few different methods by which people know to contact me if they've got anything they want me to do on stream. But in lieu of anything else, I am going to carry on with this, making this answer key, because I do need to make it. So I might as well get two birds stoned at once, as Ricky says, and you know, make some Twitch content whilst also doing up my answer key. So the next question then, question 12. There we go. Question 12 is negative 2y equals x minus 14, and then 3x plus 5y equals 30. So here again, they've tried to be a little bit sneaky, and they've moved these things around, right? They've put the x's over here. I'm going to take this one, and I'm going to rearrange that to be, I'm actually going to rearrange this one a whole bunch, but I'm going to have it be x plus 2y equals positive 14. Right? So what I did is I moved the 14 over here and the 2y over here, so I just got rid of a lot of the negatives. It's easier to work with this way. Now I'm going to take this one, and I'm going to multiply both sides by 3. So I'm going to call this 3x plus 6y is going to equal 14 times 3 is 42. Right? That's outside my times table, but I do know that 1 times 3 is 30 and 4 times 3 is 12. Okay? So then I go ahead and add. So now I'm going to bring down the other equation from above. It's going to be 3x plus 5y is equal to 30. Now they've taken it kind of easy on us, because once I go ahead and subtract these, I'm actually just going to have y equals 12. Hey, look at that. That's pretty straightforward. Hey, because 3x minus 3x is 0x, 6y minus 5y is 1y, 42 minus 30 is 12. So y equals 12, straightforward stuff. I'm going to go back and substitute in 3x plus 5 times 12 is equal to 30. 3x plus 60 is equal to 30. 3x is equal to negative 30. X is equal to negative 10. So our point of intersection here, negative 10, comma 12. Right. Yeah, for tomorrow, I tell you what I'm going to do. I'm going to make sure that I got a Desmos window ready to capture. So I can show you how to do these on an online calculator as well, which is quite useful to know how to do to check your work. Right? For now, though, yeah, let's see. What else is next on this sheet? Oh, solve by graphing. Use grids provided. Be sure to state the solution. Hey, solve by graphing. Look at that. Oh, they're telling us. They're telling us to do it this way. Oh, well, fancy. Fancy. Look at that. All right, so let's do it. Solve by graphing. Hey. There's a whole bunch of different ways to solve by graphing. Personally, because I kind of learned math from a TI-83 calculator, excuse me, I like to put them in slope intercept form, which is to say y equals something else. So this is still, as always, Math 1101C, worksheet 4. Key. Right, and once I'm back to the land of the living, I'm gonna, these are gonna be made to scan in. But for question 13 now, I want to rearrange all these guys so I get, looks like a B, doesn't it? Doesn't look like a 13. It looks like a B. You know, if 13 is an unlucky number, so should the letter B be, because B looks like a scrunched together 13. It's true. I mean, Mitch Hedberg has only ever said the truth, right? Everything the man says is 110% true. Ignoring the fact that it is mathematically impossible to give more than 100%. 5x minus y equals 7. So I want to rearrange this guy so that it has y by itself. That's not hard. 5x equals y plus 7. 5x minus 7 equals y. Pretty simple stuff, hey? Pretty simple stuff. It's easy enough to go ahead and graph now, because I know that my slope is 5 and my y-intercept is minus 7. So I can just go ahead and graph that on a grid, which don't have any grid paper ready to go. Okay. To-do sheet. Get. Okay. Boy. Look at this, making more work for myself. Boy, oh boy. This is a high effort day. Okay, so the other one then, we have 3x plus 2y equals 12. I'm going to go ahead and rearrange both these before I go and graph either. So now I'm going to have 2y equals negative 3x plus 12. Y is equal to negative 3 over 2x plus 6. So now I can go ahead and graph both these two. I could graph it by hand if I had remembered to have graph paper next to me during my stream. But tell you what, I'll graph stuff by hand tomorrow. For now, I'm just going to show you how to graph these on the old cheat machine. Okay. So if I was to go over here, clear that, and clear that, right? For one of my lines, I have 5x. Oh, and it's important when you're typing these in. Let me show you what I'm doing. Let me show you here. 5, and I use this button for x. This one, this xt theta n one here, x time. This is the one that you're going to be using for a variable whenever you're doing something like this on a TI-84 or 3 or whatever, right? If you use the x that's down here, this green one, that's actually the character x, so that if you were typing, so if I went alpha that button, it would come up with an x, but that's not the one that I want. I want this one. I want this button here. Okay? So 5x minus 7 is one of my lines, and then negative 3 over 2. I always put my fractions in a bracket like that. It makes sure that it works out correctly. Negative 3 over 2x plus 6. Now I'm going to go trace, and I might have to adjust my window depending on how well I can see. Oh, no, I can see them pretty well there. There we go. Look at that. The two of them cross. Go figure. But when you're solving by graphing, you just kind of have to use your eyes and figure out where it is. But on my calculator, I don't have to do that at all. I can go second function, trace, which is the calc thing up on top there, calc. I'm going to bring that up. I'm going to go down to number 5, which is intersect, and I'm going to hit enter, like so. First curve, right? And you notice that there's a small cursor. Here you can see it just right there. But that cursor is on one of the two lines. And you also notice up in the corner here, it tells me which line it's on currently. So this is on line Y1, which is 5x minus 7. So I'm going to say, yes, please, choose that one for my first line. Second curve, right? You see my cursor is here. I can move V. I can moving up and down. Yes, boy. I picked that one. Guess, yes, please. Intersection is 2, 3. Right, so I know from graphing my intersection is going to be 2, 3. Right, we can of course do this by any of the methods that we saw before, but again, right, we've seen that plenty of times now so far this morning. So, you know, it's getting a little bit saturated with that guy. What's the next one? I believe there's 3 more questions in this assignment in total, so I'm going to trudge through, power through, and get through these ones. And then we'll see if anybody has sent me any suggestions for topics. 14, 2x minus 3y equals negative 12. X plus 3y equals 3. So again, in order to graph it with the calculator that I have, I need to put it into slope-intercept form, which is what it's called when one side of the equation is just a y. So I need to move everything else away from the y. So we're going to have 3y. I'm going to do the second one here first. 3y equals negative x plus 3. Y is equal to negative 1 over 3x plus 1. Right. And the other one, 2x minus 3y equals negative 12. We get then negative 3y is equal to negative 2x minus 12. Y is equal to 2 over 3x plus 4. Okay, good stuff. Let's go ahead and graph it. So back to my calculator. Maybe I'll just put it down. Maybe I'll put it down and see if I can zoom in a little. Yeah. Okay, boot it up. Y equals. Clear the previous guys. See you later. Now y equals 1, and our first one I'm going to put in this one here. So I'm going to use a bracket, like I said, just to make sure that I'm that it always works out correctly. Negative 1 over 3x. That's going to be plus 1. Down here I've got 2 over 3x plus 4. Back over here to trace and just watch it unfold. Wow. Cool stuff. Okay, so second function calc, intersect. I could have hit a 5 instead of mashing down there, but you know, whatever. First curve, yes please. Second curve, also please. Guess, sure. Intersection, negative 3, 2. Cool. Point of intersection, negative 3, 2. Easy. All right, going to carry on. Going to carry on and get number 15. And do that one in blue so that I've got sort of like a crisscross pattern going. Good stuff. Number 15, so let me scroll on past that. Here we are. And to know how to graph these, I should explain that as well. Yeah, okay. So back to question 14 for a second. I will have graph paper in the future and show you how to do it by hand. But here we have a negative 1 over 3x plus 1. So we know that the y-intercept for this line has to be 1 or positive 1 right here, because that's what this number means, right? Because we have the general form of the line is y equals mx plus b, right? This one is super important to know. This is a line, right, where m is equal to your slope and b is equal to your y-intercept. Really practical, super common topic. It comes up in the general high school. It comes up in academic high school. It's all over the place. No matter what math program you're doing, you're going to see this, and you're going to use it a fair bit. Right? So here, it's the same sort of thing. We have the slope is -1/3, and slope is equal to slope is equal to rise over run. Right? So if it's -1/3, it means it rises -1 or it goes down 1 when it goes to the right 3. Our run is always to the right, right? But the rise can be either positive or negative. Positive rise means it's going up, negative rise means it's going down. So one way we could graph this if we were to graph it by hand is we put our first dot on 1 on the y-axis, and then we go to the right 3 and down 1, right 3 and down 1. Get us, 3 points or so, connect it up with a line. Same for this other line over here, right? This line going up this way. We know that our y-intercept is going to be +4, and it's going to go up 2 when it goes to the right 3. So we start here at +4, right? We go up 2 when we go to the right 3, put a dot there. Up 2 to the right 3, put a dot there. Connect it all up with our ruler. There we go. Now, when we're solving these by graphing, it kind of means just to look at it visually and inspect where it crosses. Sometimes it'll be harder to tell than others, but if you draw your lines well, you should be able to see it. Or if you're using a calculator or Desmos or other sort of thing, there's ways to get it to spit out the exact intersection. Right, so then to carry on with question 15. Question 15 is 10x minus 5y is equal to 25. And so I'm going to rearrange this one now first, because again, we're rearranging it to get y by itself. -5y is equal to -10x plus 25. Y is equal to 2x minus 5. Hey, that honestly, to me, that looks way simpler than that, right? Like, if they just gave this one to us at the start, hey, that'd be a bit too easy, right? They're not going to take it easy on you. This is a math course. It's meant to be cruel and callous and unkind. Wow, it's getting dark in here all of a sudden. Is that the Jim Gaffigan voice? 2x minus y is equal to... Holy moly, what did I just get? Okay. Yes, -2x, sorry, what am I doing? 2x minus y equals 10. Right. -y equals -2x plus 10. Y equals 2x minus 10. Okay, so we go ahead and graph them. Graph them. Two x minus 5. 2x minus 10. Now, let's take a look at these ones. What's suspicious about these guys? What do you think? This one's a good teachable moment. Actually, this is a great one. This is a great question. Finally, we got a bit of a curveball, something I can talk about. So, what do we notice about these two lines? Anybody? No. If their slopes are the same. If their slopes are the same, what are those types of lines? What do we call them? If two lines have slopes the same. Well, let's take a look at it and see. What do we have? What do we have indeed? There's one of them. There's the other one. Hey! 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 I don't see anywhere where they cross. Hey! Let me calculate and see. Intersection. First curve, yes. Second curve, yes. Guess, please. No! Error. No, sign. The reason why there's no sign is that those are parallel lines. Parallel lines, right? What does that mean? Parallel lines have no intersection. Parallel lines, therefore, no intercept. None. None at all. You can't cross them. You can't cross the streams. Okay, so one more to go here. Number 16. Make sure that I'm moving the right window. Yes, I am. Here we go. Number 16. 15x minus 10y equals 30. 3x minus 2y equals 6. Okay, so no, I wrote them both down like that, whatever. So I'm going to go ahead and solve this one here now. Negative 2y equals negative 3x plus 6. Y equals 3 over 2x minus 3. And for the other one, we have 15x minus 10y equals 30. We have negative 10y equals negative 15x plus 30. Y is going to equal to 3 over 2x minus 3. What do we notice about these lines? Anything suspicious? Well, they're literally the same line. It's the same line, isn't it? Let's see what the calculator says if we were to go ahead and graph these guys. Let's see what happens. 3 over 2x minus 3. 3 over 2x minus 3. Let's look. I mean, it's how it looks should be fine, right? Just one line, and it's still working. Let's draw another line. So, okay, we're done. All right, let's try this intersection, shall we? Let's see what it does. First curve, yes. Second curve, yes. Yes, okay. Intersection. Oh, just pick the same spot. Never you mind them. Maybe don't use the TI-84 for those ones. I figured it was going to give us some sort of interesting error code. It did not. Instead, it just gave me the point that my cursor was currently over. But here, these are the same line. Therefore, infinite intercepts. Oh, let's pretend I can spell. Right? Doesn't really matter. You can just say the same line. There we go. Okay, so 2 fringe cases. That's great. That's great. Edge cases are, yeah, it's the bread and butter, man. This is stuff to talk about. Okay, we are almost up to the time that I said I would normally go until. I said I was going to go from noon until 2:30 Newfoundland time. Yeah, days when I've got more to do, maybe I'll go for a bit longer. But with just adapting to distance teaching now, I've got a load on my plate right now. Got a bunch of stuff to go do right now with contacting students and things. If you are watching from other schools, please feel free to interact and to let me know what activities you'd like me to do. For example, if you're also in the same program, if you're at Academy Canada, yeah, absolutely, welcome on board, and please just drop in chat, say what question you would like me to solve, show some workings for, and I'll go ahead and do that. Note that I won't do any test questions, don't be silly. But anything out of the text, I'll show you how to do. No, you're very welcome. Captivating Cacti. Oh, obviously you must be one of my students then. To know you don't dox me. Oh my God. You knew my name, so of course. All right, I'll have to Yeah. So yeah, I've got some other few things to get to, but anyway, just to recap what I said, please feel free to suggest any questions for me to go over. Anyone who suggests a question, I will send them pictures of the workings afterwards. Yeah, and I intend to come here and yammer on live to the internet. Um, just to stretch my vocal cords and make it feel like I'm still teaching in class. You yeah, it's fun. And of course, if you've got any questions for the courses I teach other than math, if you're one of my students, you can let me know. I'm not going to just come on here and answer like random science and English questions because that might be a little off topic. But if you're currently working on, say, a English grammar sheet or some science notes, and you've got a quick question for me, I can field that as well. But I would like to focus on math on the stream, I think. Yeah, so that was a fun first day. Thank you all for tuning in. I hope social distancing is finding you well. I'm glad that we're all participating and getting through it together. Right? It's been, I know this is a really unique time. It's a totally unprecedented situation. No one has ever faced anything like this before. But yeah, we're all getting through it, and it's great to see people cooperating and coming through to help other people out in whatever way they can. Um, I know out in Gander, my mom, she's put up some teddy bears in the window, if for kids to drive by and see. It's a teddy bear hunt. People are out driving around, right? Because you can't, gas is super cheap, but you can't be out talking to people and gathering because of social distancing. So one fun thing they're doing for kids out there is they're putting up various teddy bears in the window, and it's a scavenger hunt for you to drive around and find the different ones. I think that's it's just a nice example of some of the cool ways that the communities are coming together to help people feel like life is still normal. And it is. It is still normal. It's just a bit of an adjustment that we're going to have to make for the time being. But anyway, thank you very much for staying and hanging out with me. I'm going to go get a whole bunch of other stuff done. Please, you can drop in any ideas for other questions to do or anything like that. Send them to me via email or via Skype. And I will get to those on the next streaming day. And anything that you submit to me for math for corrections, this is the way that I'm going to do up my feedback to send to you guys. I'll give you a grade, and then I'll also give you the feedback through video and through the stream. All right, thanks very much for tuning in. Have a lovely rest of your day, and I will hopefully see you all live tomorrow.